To lift a glass of water to your lips seems ordinary, a gesture repeated countless times across a lifetime. Yet behind the simplicity lies an unbroken chain of forces that extends back billions of years. The act is only possible because the entire universe, from its violent beginnings to its delicate balances, conspires to make water exist at all. Every sip you take is a living archive of cosmic history. If that thought unsettles you, it should. Nothing about this act is trivial. A single molecule of water is not born on Earth. Its components, hydrogen and oxygen, carry origins so far removed from the familiar that even imagining them requires stepping outside human perspective. Hydrogen atoms were forged in the first minutes after the Big Bang, when temperatures exceeded 10 billion degrees. Kelvin and particles collided in violent expansion. Oxygen, by contrast, could not emerge until stars lived and died, their cores compressing matter under unimaginable gravity before exploding outward in catastrophic supernovae. The water in your glass is thus older than mountains, older than the planet itself, and in many ways older than the very idea of life. The paradox is this: something as fragile as water, transparent and fleeting, depends on forces as vast and destructive as stellar collapse. Without cosmic violence, there is no hydration. Without destruction, there is no refreshment. Each drink you take is evidence of the same processes that shape galaxies, which means that your body relies daily on the residue of celestial cataclysms. Neuroscience often reminds us how little of this enters conscious awareness. The brain filters vast inputs of sensory data to avoid overwhelming the mind, offering only the immediate experience, the coolness of liquid against the tongue, the relief of thirst quenched. Yet hidden beneath this perception lies what psychologists call cognitive blindness, the tendency to overlook the deeper structures enabling experience. A sip of water is the perfect example. The mind encodes sensation, not origin. The result is an illusion. It feels as if the drink begins and ends at the glass, when in truth it is a chain of causation stretching back to the universe's birth. Philosophers from Heraclitus to modern phenomenologists have spoken of water as a symbol of change, flux, and impermanence. But here, symbolism intersects with empirical fact. The water in your body has been elsewhere, inside glaciers, inside rivers, inside the breath of strangers. It is statistically certain that at least a few of the molecules in your glass passed through the blood of historical figures centuries ago. Researchers like Alok Jha, in his scientific histories of water, emphasize this continuity. Drinking water is not about consumption, but participation. Each swallow draws you into a cycle older than humanity. If you have ever practiced meditation, you may have encountered the exercise of mindful drinking. Instead of simply consuming, one attends to the sensation, slowing down, noticing texture, temperature, and movement. Neuroscientific studies of such practices, including work by Judson Brewer on mindfulness and craving, show that this focus rewires the reward circuits of the brain, creating greater awareness and reducing automatic behavior. Yet what remains rarely spoken in those contexts is the unsettling dimension. When you become mindful of water, you are not just noticing your body. You are tuning into the cosmos itself. In mythology, water has always been more than a drink. Ancient cultures saw in it the axis of creation, the Egyptians with Nun, the primordial waters, the Mesopotamians with the goddess Tiamat, embodiment of the oceanic abyss, the Greeks with Oceanus, an encircling river thought to contain all existence. They intuited what science now confirms: water is not an accessory to life, but a prerequisite, a link between the microcosm of the body and the macrocosm of the universe. To sip is to enact this connection without realizing it. You may not notice it now, but as you hold a glass of water, your muscles are performing movements calibrated by evolutionary history. Grip strength, swallowing reflex, and thirst regulation are governed by neural systems that developed in response to an environment saturated by water EYES presence. In psychological terms, these are embodied scripts, patterns of behavior inscribed into your nervous system long before you were born. You inherit not only molecules from ancient stars, but also neural pathways shaped by survival around rivers and seas. What you are doing right now is not a private act. It is an extension of physics, biology, and history, converging in a moment that appears ordinary but is anything but. If the brain allowed you to see the full scale of this event, you might never swallow so casually again. And as you set down the glass, the question lingers. How can something so immediate depend so completely on the vast, unseen machinery of the universe? Hydrogen, the simplest and most abundant element in the universe, is the foundation of every molecule of water you will ever encounter. It carries within it a story that predates Earth by more than 9 billion years. Formed in the first 3 minutes after the Big Bang, hydrogen is the residue of a universe still violent and expanding, where protons and neutrons fused in temperatures so extreme that matter itself bordered on instability. The entire reservoir of hydrogen that sustains oceans, lakes, and bloodstreams was created in that brief cosmological window, after which no new hydrogen has been generated in significant quantities. To drink water is to absorb a substance as old as time's first unfolding. Oxygen has a far stranger lineage. Unlike hydrogen, it cannot emerge in the early universe. Its birth requires the life cycle of stars. Within stellar cores, hydrogen fuses into helium and helium into heavier elements through processes known as stellar nucleosynthesis. The triple alpha process, by which helium nuclei combine into carbon, creates the gateway to oxygen formation. Oxygen is then produced in abundance during the burning of carbon and neon, but it does not remain confined inside the star. Only in stellar death does oxygen scatter across galaxies. When massive stars collapse under their own gravity, supernova explosions hurl oxygen into the surrounding medium, seeding nebulae and molecular clouds with the raw material of future planets. The oxygen atom in your water glass once lay buried in the heart of a star that lived and died billions of years ago. Its death throes violent enough to create the element essential for your breath and hydration. Every molecule of water requires this improbable marriage. Primordial hydrogen meeting stellar oxygen. The sheer improbability of their convergence is masked by the abundance we now see around us. Yet astrophysical models remind us of the delicacy of this balance. Too few massive stars, and the universe would remain oxygen-poor. Too many, and the violence of supernovae would sterilize the environments where molecules could condense. Water's existence reflects not inevitability, but fragile equilibrium across cosmic scales. Physicists often describe the hydrogen atom as the most studied system in all of science, its simplicity a model for quantum mechanics itself. The electron orbiting a single proton was the foundation of Niels Bohr's early atomic theory, and later experiments confirmed quantum predictions through its spectral lines. The same atomic structure that helped us understand the probabilistic nature of reality is also the structure that makes hydration possible. To think of a sip of water is to confront quantum mechanics operating invisibly with every swallow. Oxygen's role in human consciousness extends beyond chemistry into perception. Oxygen molecules carried by hemoglobin ensure the brain maintains metabolic activity, powering the neural firing that creates awareness. Yet these molecules share the same astrophysical origin as the oxygen bound in water. The very processes that allow neurons to sustain thought depend on atoms scattered by ancient stars. To perceive a glass of water is already to participate in the consequences of cosmic detonation. In psychology, researchers speak of source neglect, the cognitive tendency to ignore the origins of an event and attend only to its immediate appearance. This bias explains why most people never reflect on the atomic age of water. Experiments on memory reconstruction, such as those by Elizabeth Loftus, reveal how easily human recollection distorts when causal chains grow too long. When confronted with origins spanning billions of years, the mind instinctively truncates the chain, collapsing it into the present moment. You experience the coolness of water without the unbearable knowledge that its atoms predate humanity by unfathomable stretches of time. Cognitive mechanisms shield you from the abyss of scale, not because the abyss is unreal, but because consciousness cannot survive constant exposure to it. Cultural traditions often tried to bridge this gap with myth. The Rig Veda speaks of waters as mothers of creation, ancient and eternal. Taoist texts portray water as the substance nearest to the Tao, the ineffable origin of all things. These are not naive projections, but early attempts to grapple with the same fact modern science reveals. Water contains within it a history beyond human comprehension. The ancients sensed what we now confirm empirically. Every drop is older than civilization. Even in modern laboratories, experiments continue to reveal the uncanny persistence of water's atoms. Spectroscopic analyses of interstellar clouds show spectral signatures of both hydrogen and oxygen floating freely in regions where stars are born. Astronomers like Edwin Salpeter, who developed models of stellar nucleosynthesis, demonstrated mathematically how these atoms spread into cosmic environments that later became planetary nurseries. Your present act of drinking is inseparable from equations written to describe stars billions of light-years away. There is no isolation here. To drink water is to interact directly with atoms that carry no memory of you, no allegiance to your biology. Yet without them, life could not unfold. Your body relies on hydrogen created in cosmological infancy and oxygen birthed in stellar death. Their fusion into water is the condition of your survival. Yet their origins remain indifferent to you. When you next raise a glass, the liquid you hold is not simply transparent fluid. It is a convergence of cosmic epochs, each sip containing particles that have traveled across eons before entering your body. To ignore that fact is natural, perhaps necessary. Yet the fact remains. You are in direct contact with matter that predates the very world beneath your feet. And once you sense that weight, the act of drinking cannot remain simple. When hydrogen and oxygen atoms first met to form water molecules, they did so under conditions that appear alien compared to the environment you inhabit now. In the cold depths of interstellar clouds, far from stars, temperatures often fall to only a few degrees above absolute zero. Here, atoms and simple molecules attach themselves to grains of cosmic dust, thin scaffolds of silicate and carbon compounds drifting silently in darkness. It is on these grains that oxygen and hydrogen combine, their union catalyzed by surfaces smaller than a single bacterium. Microscopic ice layers accrete across vast stretches of space, hidden from human senses but detectable through infrared telescopes, which capture the faint vibrational signatures of H2O bound to dust. The chemistry of water was not confined to these silent clouds. Comets, frozen bodies of ice and rock, carried vast reservoirs of water across the young solar system. Their orbits, chaotic and elongated, transformed them into couriers of molecular complexity. When a comet approached the warmth of a star, sublimation drove plumes of water vapor into space, leaving trails that intersected planetary paths. Evidence from spectroscopic studies of comets like Halley and 67P Churyumov-Gerasimenko confirms that they harbor both crystalline and amorphous water ice. preserving material from the earliest epochs of the solar nebula. The isotopic fingerprints of this ice suggest that at least some portion of Earth's water arrived through such celestial deliveries. Asteroids contributed as well. Unlike comets, many asteroids formed within the inner solar system, where heat from the nascent sun should have prevented ice from surviving. Yet certain classes, particularly carbonaceous chondrites, contain hydrated minerals that release water when heated. These rocky messengers, colliding with early Earth, may have carried enough bound water to seed oceans. The meteorite known as Murchison, which fell in Australia in 1969, released measurable water when analyzed, revealing that even seemingly barren stones conceal reservoirs of ancient hydration. Every glass of water may contain molecules once imprisoned inside rocks that traveled silently through interplanetary space before shattering against Earth's surface. The notion that comets and asteroids delivered water intersects uneasily with human psychology. In daily life, people imagine boundaries between here and out there. Space belongs to telescopes and rockets, while drinking belongs to kitchens and fountains. Yet isotopic analysis of hydrogen ratios in terrestrial oceans compared to extraterrestrial sources confirms no such divide exists. A part of every swallow originates beyond the planet. You ingest fragments of comets without ever seeing the sky they came from. This dissolves the boundary between human body and cosmic environment in ways unsettling to ordinary perception. Chemistry itself deepens the uncanny dimension. The bond between hydrogen and oxygen in water molecules is characterized by polarity, the uneven distribution of electrons creating partial charges. This polarity generates hydrogen bonds, fleeting attractions between molecules that constantly break and reform at picosecond scales. These transient interactions are why water is liquid across a wide temperature range, why it dissolves salts, and why it flows in rivers rather than sublimating into vapor. In neuroscientific terms, your capacity to remain hydrated enough to think relies on an invisible dance of charges and bonds occurring at a tempo far beyond conscious awareness. The stability of your perception depends on perpetual instability at the molecular level. In experiments simulating early planetary formation, scientists have recreated conditions where icy bodies collided with warm protoplanets, releasing bursts of vapor and depositing liquid. These simulations, conducted in high-energy laboratories, demonstrate how violent impacts transformed cosmic debris into the atmosphere and hydrosphere of Earth. Each impact carried the risk of sterilization, yet collectively they produced the essential condition for life: persistent, circulating water. To drink today is to benefit from a balance between destruction and preservation that has no guarantee of recurrence in other planetary systems. Cultures long before telescopes intuited something of this celestial origin. The Mayan Popol Vuh describes primordial waters stretching across existence before land arose. Norse mythology spoke of Niflheim, a realm of ice from which rivers poured into the void. These myths encode in symbolic form what astrophysical evidence now supports. Water descends from environments both cold and violent, carried across gulfs of space before reaching Earth. The modern laboratory confirms what ancient imagination sensed, that liquid on the tongue is inseparable from cosmic travel. Every molecule of water bears within it the memory of such journeys, though not in a form consciousness can retrieve. Neuroscientific research on embodied memory explains why humans can recall the feel of thirst or the pleasure of relief, but cannot intuit the atomic lineage of the water itself. The hippocampus encodes personal experience, not cosmological history. You experience water as immediate refreshment, not as the residue of cometary impact. Yet the molecules do not forget. Their very presence in your glass testifies to collisions and accretions across geological and astronomical timescales. The unsettling truth is that the act of drinking positions you within a continuum of events stretching across space and time. Events that could easily have unfolded differently. A slight alteration in the early solar system's architecture, a shift in orbital resonance, or a change in impact frequency, and the Earth you inhabit might never have acquired the volumes of water it holds today. The sensation of cool liquid against the tongue is contingent on a history that required both improbability and precision. And when you confront that contingency directly, the act of lifting a glass no longer feels insulated from cosmic scale. Each swallow becomes a reminder of collisions you never witnessed, of dust grains you never touched, of comets that burned before your species existed. The water you drink is not simply present. It is carried, delivered, and preserved through processes indifferent to you, yet essential for you. What remains to be considered is how such improbable arrivals shape the planet into one capable of sustaining liquid long enough for you to exist at all. When Earth emerged from the swirling remnants of the solar nebula, it was not a world of oceans, but a hostile sphere of molten rock. Heat from constant bombardment, radioactive decay, and gravitational compression kept its surface in a state of violent flux. Any water that might have existed in vapor form was repeatedly stripped away by solar winds, leaving the young planet arid and unstable. It took the gradual formation of a magnetic field and the accumulation of an atmosphere to create conditions in which water could remain, condense, and gather into basins. Without these shields, every molecule would have drifted back into the void. The arrival of water-bearing comets and asteroids left not only oceans, but traces locked into minerals deep within the crust. Recent geochemical studies of zircon crystals, some of the oldest minerals on Earth, suggest the presence of liquid water as early as 4.4 billion years ago, only 100 million years after the planet formed. These microscopic crystals, analyzed through isotopic ratios of oxygen, carry signatures consistent with interaction with water, indicating that even in its infancy, Earth already bore traces of the element that would define its future. What you drink today may contain molecules that first circulated when the planet's surface was still reshaping under relentless bombardment. As the crust solidified and volcanic activity released gases, Earth's primitive atmosphere began to trap water vapor. Thick clouds formed, and over spans of time so vast they elude human imagination, rains fell incessantly, filling basins that had cooled enough to hold liquid. The oceans, once established, became not merely reservoirs, but engines of planetary regulation. Their mass absorbed heat, stabilized climate fluctuations, and provided the chemical medium in which life itself could emerge. Every organism that evolved carried the imprint of water's dominance, adapting to its solvent properties, its density, its ability to dissolve and transport ions essential for metabolism. Water became not just a background condition, but the primary architect of geological features. Glaciers carved valleys, rivers sculpted plains, rainfall eroded mountains, and waves reshaped coasts. Each landscape humans inhabit is, in some sense, a record of liquid persistence. Neuroscientific research on environmental perception suggests that humans intuitively gravitate toward water-rich environments, rivers, lakes, seas, not only for survival, but because the brain encodes them as signals of fertility and safety. Evolutionary psychology proposes that this preference, embedded across generations, influences aesthetic judgments even today. The sight of water in a painting, photograph, or cityscape can activate reward circuitry in the brain, mirroring the evolutionary necessity of proximity to hydration. The idea that Earth's water is locked into multiple domains, oceans, glaciers, subterranean aquifers, reveals another layer of dependence. Deep within the mantle, water exists not as liquid but bound within minerals, forming what geophysicists call deep water reservoirs. These hidden stores may contain volumes comparable to surface oceans, yet remain inaccessible and invisible, released only through volcanic activity or tectonic shifts. The cycle is slow, spanning millions of years, but it underscores how water is not confined to familiar forms. When you drink from a glass, you participate in a planetary circulation that moves through channels, most of which you will never see. Cultural imagination, long before geophysics, sensed these hidden dimensions. In ancient Mesopotamia, the freshwater abyss known as the Apsu was believed to lie beneath the earth, feeding rivers and springs. Greek mythology spoke of Oceanus encircling the world, while Hindu cosmology described subterranean waters flowing through invisible channels. These symbolic interpretations, though not scientific, mirror the geological truth. Water is stored, concealed, and redistributed through layers of the planet that remain beyond perception. What people imagined as deities or sacred abysses are in reality mineral-bound molecules, moving in cycles older than civilizations. The precarious balance of Earth's water was always contingent on planetary scale. Mars, smaller and less protected by atmosphere, lost most of its water to space, leaving behind dry riverbeds and polar ice caps as reminders of what once flowed freely. Venus, closer to the Sun, endured a runaway greenhouse effect that stripped oceans into vapor and left an atmosphere choked with carbon dioxide. Earth alone among its neighbors retained the delicate equilibrium, allowing liquid water to persist on its surface for billions of years. Every sip you take is possible only because your planet occupies a position where solar radiation, atmospheric thickness, and gravitational retention align within narrow thresholds. Modern measurements of isotopic composition show that water molecules on Earth remain in ceaseless circulation between these domains: ocean, glacier, aquifer, atmosphere, shifting from one reservoir to another through cycles of evaporation, precipitation, and runoff. Yet the illusion of stability persists in the mind. You lift a glass, and the water seems static, isolated, as though it began at the faucet and ends in your body. Cognitive psychology calls this the object permanence bias. The brain prefers to see discrete, stable entities rather than transient nodes in a larger system. This bias shields daily perception from the disquieting fact that the water you hold was once vapor drifting high in the stratosphere, and will one day return there, carried outward through the same cycle that sustains all life. To recognize this is to confront dependence at its deepest scale. The act of drinking does not end with you. It engages reservoirs beneath continents, glaciers at the poles, clouds across the sky. It ties you to tectonic forces, to volcanic plumes, to atmospheric currents spanning hemispheres. It reminds you that your survival is contingent not on isolated molecules, but on a planetary system balancing collapse and persistence. And when you consider how narrow this balance is, how easily water might have escaped or boiled away as it did elsewhere, the ordinary glass in your hand begins to feel like a fragile accident suspended in time. Liquid water's capacity to endure on Earth has always depended on the grip of gravity. Without sufficient mass to tether an atmosphere, water vapor would have drifted into space, lost irretrievably to solar winds. Earth's gravitational pull, calibrated within a narrow range, held gases close enough to sustain pressure at the surface, allowing liquid water to exist rather than dissipating into vacuum. This gravitational retention explains why the oceans do not simply boil away under the sun's constant energy, and why clouds can gather above mountains rather than dispersing into infinite dispersal. The same gravity that secures water on the planet also gives it shape. Waves rise and fall in response to tidal forces, themselves driven by the gravitational interplay between Earth, Moon, and Sun. Each tide is not a local phenomenon, but a planetary flexing of liquid, pulled by celestial bodies across a sphere rotating in space. To stand at a shoreline and watch the water rise is to witness gravitational choreography extending beyond the horizon. The glass you drink from participates in that choreography. Its molecules respond invisibly to lunar pull, their positions shifting in infinitesimal synchrony with tides that move entire oceans. Without atmospheric pressure maintained by gravity, liquid water could not exist in familiar form. On Mars, where pressure is less than 1% of Earth's, liquid water cannot remain stable on the surface. It either freezes into ice or sublimates directly into vapor. Laboratory experiments simulating Martian conditions show water boiling at near room temperature, a phenomenon impossible on Earth because of atmospheric constraints. Each sip from your glass, steady and uneventful, is made possible by the precise pressure exerted by the column of air above you. The weight of the atmosphere, though invisible, presses on every molecule, preventing it from escaping into the void. In physics, the balance between gravitational attraction and molecular energy is described as escape velocity. A planet's ability to retain water depends on whether the average speed of water vapor molecules at given temperatures is lower than the velocity needed to overcome gravity. For Earth, that condition is narrowly met. Water molecules at typical atmospheric temperatures remain bound, while lighter gases such as hydrogen and helium escape. This balance means that your body, largely composed of water, is preserved on a planet where molecules cling just enough to remain, but not so much that all motion ceases. Psychological perception rarely acknowledges this dependence. Studies in embodied cognition reveal that humans treat gravity as an unexamined background, an unchanging constant that requires no attention. Neuroscientific research into the vestibular system, responsible for balance and spatial orientation, shows that the brain encodes gravitational pull through the inner ear's otolith organs. Yet these signals remain below conscious awareness unless disrupted by conditions such as weightlessness. Astronauts often report profound disorientation when liquids behave unpredictably in microgravity, forming floating spheres rather than pouring. To watch water defy terrestrial behavior in orbit is to realize that drinking itself is a privilege of planetary confinement. Ancient mythologies often elevated gravity's counterpart, the sky, to divine status while treating the waters below as subordinate. Yet in traditions such as Hindu cosmology, the concept of Mount Meru as the axis of the world subtly encoded an understanding of balance and weight, positioning Earth and water within a gravitational order. Even without physics, cultural imagination sensed that stability required forces unseen, pressing down and binding worlds together. Geophysics extends this dependence beyond oceans and tides. Water deep within aquifers and rock fissures is held in place not only by geological structures, but by gravitational pressure maintaining flow and storage. Remove that pressure, and underground reservoirs would cease to function as they do, disrupting ecosystems that depend on their release into springs and rivers. Each draw of groundwater carries with it a reminder that unseen forces compress and regulate hidden networks beneath your feet, systems as reliant on weight and pull as the tides above. Consider the paradox. Gravity is simultaneously the force that threatens to collapse everything inward, and the condition that permits water to pool, flow, and circulate. Its indifference creates both crushing pressure in ocean depths and gentle waves at the shore. Neuroscience suggests humans are poorly equipped to grasp such scales. The brain's parietal lobe handles spatial reasoning, but it evolved for immediate survival tasks, throwing, reaching, walking, not for comprehending planetary-scale curvature. The glass in your hand appears level, though it sits on a curved sphere where water is pulled toward a center you will never touch. Perception collapses scale into manageable illusions, hiding the enormity of forces shaping each swallow. Even technology designed to manipulate water cannot escape these constraints. Reservoirs, dams, and aqueducts all rely on gravity to guide flow. Engineers exploit differences in potential energy, channeling water from high to low, Yet they do not create the flow. They only redirect what gravity dictates. When you turn on a tap, the stream that emerges is not powered only by pumps, but by a fundamental pull that has operated since the planet coalesced. This dependence is fragile. A world with slightly weaker gravity or thinner atmosphere would lose water to space, leaving no rivers, no oceans, and no bodies capable of hydration. A world with stronger gravity might trap atmospheres so dense that liquid water could not remain accessible on the surface, compressing conditions beyond biological tolerance. Earth exists in a narrow band, a coincidence of magnitude, where gravity exerts just enough pull to sustain the liquid you casually drink. Every glass, then, is not simply a container of fluid, but a demonstration of planetary mass expressed in liquid form. To drink is to rely on a balance you did not create, a balance that remains vulnerable to shifts at scales beyond human control. And when you pause long enough to notice, the question begins to surface. What other forces, equally invisible and equally indifferent, must align to keep that liquid cycling across the planet and back into your hand? The sun's role in sustaining liquid water is not gentle illumination, but relentless radiation. Every drop you drink is shaped by energy that has traveled across 150 million kilometers, released in the nuclear furnace of the solar core. There, hydrogen atoms fuse into helium through the proton-proton chain, releasing photons that scatter outward in random walks lasting tens of thousands of years before escaping the star's surface. The light that warms oceans and drives evaporation began its journey before the first humans evolved. By the time it strikes Earth, it carries within it the record of stellar fusion, invisible yet indispensable to the cycle that delivers water to your glass. Solar energy powers evaporation at the surface of seas and lakes, lifting molecules into the atmosphere where they condense into clouds. Without this constant input of energy, liquid water would remain stagnant, locked in basins without circulation. The hydrological cycle, the endless movement of water between ocean, air, and land, depends entirely on the sun's radiation. Studies of paleoclimate confirm this connection. Ice core records from Greenland and Antarctica reveal layers encoding fluctuations in solar intensity, mirrored in variations in rainfall and drought across millennia. To drink water today is to sip from a system continually sculpted by the sun's shifting output. The transformation from liquid to vapor and back again conceals a hidden dimension. The phase changes require vast exchanges of latent heat. When water evaporates, it absorbs energy without changing temperature, carrying that energy upward into the atmosphere. This hidden heat drives weather systems, powering storms and distributing moisture across continents. Each glass of water embodies this unseen energy flow, its molecules once lifted by solar radiation into the sky before descending again as rain. Meteorological research demonstrates that hurricanes draw their force from this same mechanism, releasing energy stored in evaporated water when condensation occurs. Your act of drinking is linked, invisibly but directly, to the forces that generate planetary storms. The human body is tuned to these rhythms. Circadian biology shows that light exposure regulates not only sleep cycles, but hydration patterns. The suprachiasmatic nucleus of the hypothalamus responds to solar cues, synchronizing thirst mechanisms with day and night. Experiments demonstrate that disruptions in light exposure, such as during extended polar darkness, alter hydration behaviors and electrolyte regulation. Even at the level of personal biology, your urge to reach for water follows signals ultimately dictated by the sun. Yet the sun's influence is precarious. Too much radiation, and water evaporates beyond recovery, as Venus demonstrates with its desiccated atmosphere and runaway greenhouse effect. Too little, and water freezes into perpetual ice, as Mars shows with its polar caps. Earth occupies a narrow orbital band, the so-called habitable zone, where solar energy maintains water in liquid form across wide regions. This band is not wide enough to guarantee permanence. Its stability depends on subtle interactions between atmosphere, magnetosphere, and orbital distance. Each sip you take is contingent on this equilibrium, a balance that could tilt with shifts in solar output or orbital mechanics. Cultural traditions often encoded reverence for the sun, not only as a source of light, but as the regulator of waters. In ancient Egypt, the sun god Ra traveled daily across the sky, his journey ensuring the inundation of the Nile. In Andean cultures, solar rituals coincided with agricultural cycles tied to rainfall. Such symbolic frameworks mirrored the empirical truth. Without solar radiation, rivers would not rise, clouds would not gather, and water would not return to refill wells. Myth and observation converged on the same principle, that every drop depends on energy streaming from a star. Modern solar research uncovers further complexity. Variations in solar cycles, marked by sunspot activity, influence patterns of precipitation across continents. Historical analyses connect the Maunder minimum, a prolonged period of low solar activity in the 17th century, with cooler global temperatures and shifts in rainfall that altered harvests and shaped economies. Drinking water today is tied not just to present sunlight, but to centuries of solar fluctuations recorded in hydrological systems. Every molecule in your glass has circulated under conditions shaped by a star whose variability reaches across centuries. Neuroscience adds another layer. Sensory experience of drinking, coolness, wetness, relief, is encoded in the brain as immediate, yet the underlying processes are astronomical in scale. This mismatch reflects what cognitive scientists call scale blindness, the inability to reconcile direct perception with processes operating across temporal and spatial magnitudes beyond experience. The tongue registers cool liquid, but the molecule itself was carried upward by radiation that left the solar surface before you were born. Consciousness compresses the scale, hiding the enormity behind the sensation. Even technological attempts to manipulate water remain subject to solar dependency. Desalination plants, reservoirs, and irrigation networks cannot function without the hydrological cycle, replenished by evaporation and rain. Every system humans construct assumes that the sun will continue to deliver energy sufficient to move water from ocean to sky to land. Should solar output falter or accelerate, no engineering could fully compensate for the disruption. The ordinary act of filling a glass is therefore not insulated from astrophysical contingencies, but embedded within them. To dwell on this connection unsettles the sense of autonomy. Each sip you take is conditioned not by your intention alone, but by nuclear reactions occurring 150 million kilometers away. Reactions utterly beyond human control. The glass in your hand, the water on your tongue, the moisture in your blood. Each depends on the ongoing stability of fusion within a star. And once you realize how narrow that margin is, you begin to wonder what would unfold if the flow of energy were to shift, even slightly, altering the cycles that deliver water back into your reach. Within the human body, water ceases to be a passive substance and becomes the medium through which life organizes itself. Every cell you possess, from neurons to muscle fibers, is immersed in an aqueous environment. Cytoplasm is not merely a backdrop for cellular machinery, but a dynamic solvent where proteins fold, enzymes catalyze, and ions move along gradients that sustain electrical activity. Without water's peculiar polarity, capable of dissolving salts and stabilizing charged particles, the biochemical choreography of life could not proceed. To drink a glass of water is to replenish the very stage upon which biological processes unfold. The nervous system depends acutely on this medium. Neurons communicate by propagating electrical impulses, but those impulses arise only because sodium, potassium, calcium, and chloride ions dissolve in water and traverse membranes through specialized channels. Each thought, memory, or sensation is inseparable from the solvent properties of water. Neurophysiological studies show that even mild dehydration alters neuronal excitability, slowing reaction times and impairing attention. The difference between clarity and confusion, between wakefulness and fatigue, often rests on the presence of enough water molecules to sustain ion flows invisible to perception. Beyond conductivity, water regulates temperature, buffering the human body against environmental extremes. Sweating, a uniquely human adaptation among primates, relies on water's high heat capacity and evaporation properties. Anthropologists argue that this ability to dissipate heat allowed early humans to hunt and travel across open savannas, outlasting prey animals that overheated under the sun. The act of drinking today maintains that evolutionary adaptation, enabling a body to perform labor, endure heat, and sustain brain function over long durations. What feels like relief from thirst is also the continuation of a physiological strategy that shaped the trajectory of an entire species. In circulation, water carries nutrients, hormones, and waste. Blood plasma, comprising more than 90% water, transports glucose to neurons, oxygen to tissues, and metabolic byproducts to kidneys for excretion. Each heartbeat propels this liquid matrix through a vascular network extending over 90,000 kilometers. The sensation of swallowing a glass of water belies its destiny. Distribution through vessels to sustain trillions of cells. Studies in medical physiology confirm that blood viscosity changes measurably with hydration status, altering cardiovascular load. Each sip modifies the balance of pressure and flow that your heart must manage with every contraction. Even the mechanics of swallowing depend on water's role in lubricating tissues. Saliva, composed largely of water, enables the tongue to form a bolus and the esophagus to transport it downward. Without adequate hydration, the act of swallowing becomes difficult, painful, or impossible. The very gesture that feels so natural is supported by molecular structures working in synchrony with fluid properties. Speech itself, air moving across vocal folds lubricated by thin films of water, depends on this same system. To voice the thought of thirst requires the very substance that quenches it. On a broader scale, water shapes cognition and mood. Psychological experiments demonstrate that dehydration influences not only memory and attention, but emotional regulation. Research led by Lawrence Armstrong and others found that subjects deprived of fluid for even a few hours reported increased tension, anxiety, and fatigue. Neuroimaging reveals that the anterior cingulate cortex, a region involved in emotional processing, activates strongly in response to thirst states. Drinking restores balance not only to tissues, but to the circuits that govern emotional experience. Relief from thirst is both bodily and psychological, an intersection where molecules and mood converge. Evolution embedded this necessity deeply in the brain. The hypothalamus contains osmoreceptors that detect changes in blood concentration, triggering thirst when water levels fall. These signals bypass higher cognition, producing a compulsion difficult to ignore. Neurotransmitters such as vasopressin regulate kidney function in tandem with this drive, ensuring conservation of water when intake is low. The compulsion to drink is not an option, but a directive, hardwired into the machinery of survival. To resist it for long is to encounter confusion, hallucination, and collapse as neural circuits deteriorate without their solvent. Cultural practices reflect this dependence. Rituals surrounding water, ablutions in Islam, baptism in Christianity, purification rites in Hinduism and Shinto, mirror not only symbolic meanings, but biological imperatives. The act of cleansing or drinking is elevated to spiritual necessity because the body cannot distinguish between the sacred and the physiological when water is withheld. Anthropologists studying desert cultures document elaborate customs for storing and sharing water, reinforcing the understanding that survival and community are bound to its presence. In each case, biology and culture converge on the same recognition. Water sustains both the flesh and the meaning humans attach to life. Yet the illusion persists that drinking is a trivial act, one easily dismissed. The glass seems small, the gesture routine, the liquid ordinary. What perception conceals is the chain of dependencies linking that moment to the entire structure of physiology, evolution, and culture. The brain edits away the abyss of reliance to protect attention from being consumed by it. But once attention turns toward it, the act is no longer trivial. Each sip becomes evidence of a system that can unravel with surprising speed if the flow of molecules ceases. Hydration is therefore not merely a matter of comfort, but of existence balanced on narrow margins. Neural excitability, thermoregulation, circulation, digestion, and cognition all hinge on molecules that must be replenished continually. The sensation of thirst is not optional discomfort, but the body's alarm that its substrate for survival is dwindling. And when you allow yourself to confront how absolute that dependence is, a new unease emerges. Water sustains you only because it is continually recycled through systems far larger than you, systems that extend into forests, seas, and skies beyond your reach. The water that moves through your body today is not fixed in place. It belongs to cycles that have operated on planetary scales for billions of years. Each molecule shifts between states and reservoirs, traveling from ocean to atmosphere, from glacier to river, from soil to root. Hydrologists describe this as the global water cycle, a system so vast that no drop remains untouched by it. Yet this system is not abstract. It enters your life directly with every swallow, connecting you to processes that span continents and centuries. Rain that falls on a forest canopy may spend weeks traveling through leaves, stems, and soils before reaching an aquifer. The same water, once absorbed by roots, becomes part of xylem flow, rising against gravity through capillary action and cohesion between molecules. At the leaf's surface, it evaporates again, released as vapor into the air in a process called transpiration. This continuous exchange between vegetation and atmosphere creates what climatologists term biotic pumps, where forests regulate regional rainfall. The Amazon rainforest alone releases more than 20 billion tons of water into the air each day, shaping precipitation patterns across South America. To drink a glass of water in a distant city may depend on rainfall patterns maintained by forests thousands of kilometers away. Ice, too, plays its part in this cycle. Glaciers, which lock away vast volumes of water, serve as delayed-release reservoirs. Seasonal melting delivers fresh water to rivers that sustain agriculture and populations across Asia, Europe, and the Americas. The Himalayan glaciers feed the Ganges, Brahmaputra, and Indus. Their slow retreat over centuries shapes the survival of millions. Ancient ice cores drilled in Antarctica contain bubbles of air and molecules of water older than recorded history. Evidence that your drink today once circulated through climates radically different from the present. To sip is to engage with a cycle recorded in frozen archives beneath kilometers of ice. Rivers and groundwater form another link. Aquifers, hidden beneath layers of rock and soil, discharge through springs that create lakes and streams. Some aquifers recharge slowly, taking thousands of years to replenish, which means that a portion of the water drawn from them is older than civilizations. Hydrological dating using isotopes such as tritium and carbon-14 confirms that human industry often extracts fossil water, liquid that has been trapped underground since prehistoric times. A glass filled today may contain molecules that last moved freely before cities or writing existed. The oceans dominate all these systems, covering more than 70% of Earth's surface and holding 97% of its water. Their sheer mass moderates temperature, drives currents, and generates weather. When evaporation lifts molecules into the atmosphere, they may travel across entire oceans before condensing again as rainfall. Isotopic studies trace specific pathways, showing how water evaporated in the tropics can later fall as snow in the Arctic. To drink in one hemisphere is to engage indirectly with cycles sustained by evaporation in another. Psychological perception cannot follow such trajectories. Cognitive science demonstrates that humans are predisposed to think locally, an adaptation favoring immediate survival but ill-suited to global cycles. The mind perceives water as beginning at the faucet or stream, ending in the mouth. Yet, the hydrological cycle disregards these boundaries. Your glass contains water that once flowed in the breath of strangers, the sap of trees, the veins of animals, or the exhalations of volcanoes. Researchers at NASA's Goddard Institute use atmospheric models to track these flows, revealing that molecules of water can circle the planet in less than 2 weeks. The substance you drink is not confined by borders, but moves across landscapes with indifference to ownership. Cultural imagination often tried to capture this interconnectedness. Ancient Greek philosophy described water as one of the 4 elements, a fundamental substrate linking all matter. Indigenous traditions across the world recognized rivers as kin, clouds as ancestors, rain as blessing or omen. These perspectives, though not derived from modern hydrology, anticipated the insight that every body of water is linked, every sip a continuation of a planetary cycle. What myth expressed symbolically, science now demonstrates with isotopic tracers and satellite imagery. Yet the cycle is not stable. Climate research documents shifts in rainfall distribution, accelerated glacier melting, and aquifer depletion. These changes alter the availability of drinking water for billions, reshaping agriculture, migration, and survival. What seems like a glass filled with stable liquid is in fact contingent on patterns vulnerable to disruption. The molecule you drink today may be part of a cycle altered tomorrow by forces you cannot see. Deforestation, atmospheric warming, industrial extraction. Each sip, then, carries with it not only history, but uncertainty. Neuroscience frames this disquiet as cognitive dissonance. The brain prefers consistency and predictability, but the water cycle embodies flux and transformation. The same molecules move through bodies, landscapes, and skies, ignoring human boundaries of time and place. To drink is to participate in a system you cannot control, one that sustains you while offering no guarantee of permanence. The act reveals dependence on forces larger than perception, forces that continue whether or not you attend to them. Once you confront this dependency, the question lingers: if every sip is drawn from a cycle that ties forests, glaciers, rivers, and oceans into one vast circuit, what deeper forces allow the very existence of these cycles? And what hidden conditions ensure that the molecules you hold in your hand continue to circulate at all? The existence of circulating water presupposes the deeper architecture of the universe itself. Each molecule is the consequence of laws and constants that remain consistent across space and time, shaping not only chemistry, but the possibility of life. The strength of the electromagnetic force allows hydrogen and oxygen to bond at just the right energies. The relative weakness of gravity compared to electromagnetism permits stars to fuse hydrogen into heavier elements without collapsing instantly. The quantized structure of matter ensures that stable atoms persist rather than decaying into chaos. To drink a glass of water is to encounter these fundamental conditions embodied. The stability of the cosmos condensed into liquid form. Astrophysicists often describe water as a cosmic bridge, linking microscopic quantum mechanics to macroscopic cosmic order. Its molecular geometry, 2 hydrogen atoms bent at an angle from oxygen, creates polarity, enabling hydrogen bonding. These transient connections are responsible for water's anomalous properties, expansion upon freezing, unusually high surface tension, and its role as a universal solvent. Had the laws of physics been slightly different, these properties might not exist. Without expansion upon freezing, ice would sink rather than float, eliminating the insulating layers that protect aquatic life during winters. Without solvent capacity, biochemical processes would stall. Your capacity to lift a glass rests on laws that emerged at the universe's birth and remain unchanged through epochs. The anthropic principle, debated in cosmology, addresses this tension. The universe appears finely tuned in ways that permit life. Water embodies this principle directly. If the strong nuclear force were fractionally stronger, hydrogen might not exist as a stable element, eliminating water entirely. If it were weaker, carbon and oxygen could not form in sufficient abundance. A sip of water is not inevitable. It is contingent on parameters balanced across scales no human can alter. Each swallow reaffirms that your body thrives only because the universe itself allows chemistry to behave within narrow margins. Psychology grapples poorly with such abstraction. Humans evolved to process immediate threats and rewards, not cosmic fine-tuning. Cognitive science refers to this as temporal compression, the tendency to collapse vast histories into manageable narratives. When you drink, you experience sensation, not cosmological precision. Yet the liquid sliding across your tongue could not exist without nuclear fusion inside ancient stars or constants calibrated across billions of light years. The brain edits away these scales to preserve coherence, but they remain embedded in every molecule consumed. Cultural traditions sensed this uncanny link between ordinary substance and cosmic order. In Taoist thought, water is revered as a symbol of the Tao itself, formless, yielding, yet sustaining. In Stoic philosophy, the logos, the rational structure of the cosmos, was often illustrated through natural phenomena like rivers and seas. These metaphors were attempts to articulate what physics now quantifies, that ordinary experience is possible only because of structures that operate far beyond perception. Water, in its transparency, hides the universe's architecture even as it embodies it. Modern experiments illuminate this connection further. Particle accelerators probing the behavior of protons and electrons confirm the same quantum rules that stabilize water molecules. Satellite telescopes scanning interstellar space detect water vapor in nebulae thousands of light-years away, proving that the same chemistry exists universally. Laboratory spectroscopy and cosmic observation converge. The same laws govern both the glass on your table and the clouds of Orion. To drink water is to bridge the laboratory and the cosmos in a single act. Yet the stability of these laws should not be mistaken for permanence of conditions. Cosmologists predict that stellar fusion will one day cease as stars exhaust their hydrogen. The abundance of oxygen will diminish as fewer supernovae scatter it. Water itself, though stable, depends on cycles powered by forces that change across epochs. To drink today is to participate in a fleeting window when the universe still supports liquid oceans, breathable air, and biological metabolism. Neuroscience reveals how unfit the human mind is to dwell on such horizons. Studies of existential awareness show that when people are confronted with scales that extend beyond comprehension, they experience disorientation, sometimes described as the overview effect when reported by astronauts. The sensation of insignificance can destabilize perception, triggering both awe and unease. A glass of water, approached with awareness of its cosmic dependencies, can induce a miniature version of this state. The realization that something so ordinary is sustained by forces that exceed not only perception, but survival itself. What unsettles most is the recognition of dependence. You cannot will the constants of physics to remain stable, nor can you ensure that stars will continue scattering oxygen across galaxies. Yet your very blood, your very thoughts, rely on these processes remaining as they are. To drink is to admit that you exist only on condition of cosmic balances that remain indifferent to you. The illusion of autonomy dissolves into recognition of participation in a structure far larger and less forgiving. And once you allow yourself to follow that recognition to its limits, the glass in your hand becomes something else entirely, a point of contact between biology and the cosmos, a temporary alignment of matter that could easily have been otherwise. What remains unresolved is not the presence of water itself, but whether the conditions that allow it to flow, cycle, and sustain will endure across the scales of time still unfolding. The glass of water in your hand is not a self-contained entity, but a brief configuration of molecules drawn from systems that never rest. Oceans exchange moisture with skies. Soils exhale vapor into winds. Glaciers calve and melt. Rivers flood and recede. The scale of these cycles makes ownership an illusion. The water you claim for yourself will soon return to pathways indifferent to your use. Even within the body, it is only borrowed, moving constantly through blood, lymph, tissues, and excretory systems before rejoining the environment. You are never more than a temporary custodian of molecules that belong to no one. Forests orchestrate these movements with precision often overlooked. Through transpiration, leaves release vast amounts of vapor that rise to form clouds, influencing rainfall thousands of kilometers away. In the Amazon basin, moisture evaporated from vegetation cycles back into rainfall multiple times before reaching the Atlantic, a self-sustaining atmospheric engine. Remove the forest, and the rainfall patterns collapse, drying soils and altering river flows. To drink a glass of water in a distant city is to rely unknowingly on photosynthesis and evaporation occurring in canopies you may never see. Hydrological models confirm that entire agricultural regions depend on these invisible exchanges, which operate silently above the tree line, yet dictate whether water arrives at human settlements. The same principle holds for oceans, which are not passive basins but engines of circulation. Driven by differences in temperature and salinity, massive currents transport water across hemispheres, redistributing heat and nutrients. The Gulf Stream, for example, carries warm water from the tropics toward Europe, moderating climates that would otherwise be subarctic. Evaporation along these pathways seeds clouds that deliver rainfall across continents. Paleoclimate records reveal that disruptions in ocean currents have coincided with abrupt changes in rainfall patterns, reshaping ecosystems and civilizations alike. The glass you hold is tied to vortices and gyres, larger than any nation, spirals of moving water whose inertia spans centuries. Groundwater, hidden beneath layers of rock, complicates this picture further. Unlike surface rivers, many aquifers replenish slowly, at rates imperceptible on human timescales. Extraction from these hidden reserves has accelerated beyond recharge capacity in many regions, meaning that water drawn today may not return for millennia. Isotopic dating of aquifers in North Africa and the Middle East confirms that some contain water trapped since the last ice age. To pour such water into a glass is to drink from climates long vanished, to absorb molecules that circulated when mammoths roamed and glaciers covered continents. Cognitive psychology explains why these scales remain invisible. Humans perceive water in terms of immediacy, flowing, pouring, quenching, not in epochs or planetary feedback loops. The brain truncates causal chains, presenting the illusion of simplicity, where complexity reigns. Yet beneath that illusion, each molecule carries trajectories that stretch backward into prehistory and forward into futures yet unwritten. What seems stable is, in fact, restless movement across scales beyond direct perception. Myth and ritual often acknowledged this restlessness. In Shinto traditions, rivers and springs are inhabited by kami, spirits that remind communities that water is alive, never fully possessed. In ancient Greece, naiads guarded streams and fountains, embodiments of the same recognition. These cultural forms encoded truths that hydrology now verifies. Water is a process, not a possession. It flows through human bodies as briefly as it flows through valleys, refusing permanence in either. Modern technologies, despite their sophistication, remain subject to these flows. Reservoirs can store water for decades, but droughts deplete them as quickly as storms fill them. Desalination converts seawater to fresh water, yet it cannot alter the energy of evaporation that drives climate. The systems humans construct operate within larger cycles that disregard national borders and engineering ambitions. No infrastructure creates water. It only diverts what cycles already provide. To drink is still to rely on processes beyond deliberate control. Even perception itself is shaped by these dependencies. Neuroscientific studies on interoception, the sense of the body's internal state, reveal that the human brain monitors hydration through signals from blood osmolality. Yet the sensation of thirst does not arrive until imbalance is significant. This lag ensures survival, but also enforces dependence. By the time you feel compelled to drink, the body has already been negotiating with shortages for hours. Hydration is not a choice freely exercised, but a compulsion written into the nervous system by evolutionary necessity. The water you ingest is less about preference than submission to demands inscribed in physiology long before thought. What unsettles most is the fragility of these interconnections. Forests can vanish, glaciers can retreat, aquifers can collapse, currents can stall. Each sip depends on balances that remain vulnerable to disturbance, balances that require no conscious awareness to unravel. When you swallow, you rely not only on molecules present in your glass, but on entire systems maintaining circulation at scales you cannot perceive. And when that realization deepens, the question arises with more force. If these planetary cycles are themselves dependent on the structure of the cosmos, what further conditions must align, beyond forests and oceans, beyond glaciers and aquifers, to ensure that water continues to exist in any form at all?